Question 1. For each statement below, indicate whether the answer is true or false. Statement 1. AI solutions today are commonly built on machine learning models that capture semantic relationships from large datasets. Answer: true. Statement 2. Developers building modern AI applications typically combine machine learning models, AI services, prompt engineering, and custom code. Answer: true. Statement 3. Decision support in AI focuses on generating free-form text rather than making predictions from historical patterns. Answer: false. Statement 4. Agents in generative AI are limited to answering questions and cannot take actions such as initiating tasks. Answer: false. Now I will explain each choice step by step so it all clicks. First, Statement 1 is true because most real systems lean on models trained on massive data to learn semantic relationships, which lets them interpret inputs and generate useful outputs. Next, Statement 2 is true, since practical apps rarely rely on a single model. Instead, they blend cloud AI services, careful prompt design, and custom code to meet real-world needs efficiently. However, Statement 3 is false because decision support is fundamentally about predictions and recommendations based on patterns in historical data, not merely free-form generation. For example, forecasting customer churn relies on past behavior to predict risk. Finally, Statement 4 is false since modern agents can assess context and take actions such as sending summaries, triggering workflows, or scheduling tasks after reasoning about user goals, which goes beyond just answering questions. Question 2. For each AI capability, drag it to the appropriate boxes in the correct match column to match it against its description in the option column. Each item may be used once, more than once, or not at all. Generate original responses to natural language prompts. Generative AI, autonomous task-taking applications that can interpret input and act. Agents, accepts, interprets, and processes visual input. Computer vision, recognizes and synthesizes spoken language. Speech, processes natural language to analyze, summarize, and categorize. Natural language processing, extracts key fields from documents, images, or recordings. Information extraction, uses historical data and learned correlations to make predictions for decisions. Decision support. Now let's go through the explanation together, so it all connects clearly. Generative AI is matched with generating original responses because it creates new content from natural language prompts, just like how AI chat systems produce written or visual output. Agents are linked to autonomous task-taking since they interpret input and act independently, for instance, managing workflows or sending updates. Computer vision aligns with visual processing, as it enables AI to interpret images, video, and camera feeds to identify objects or patterns. Speech corresponds to recognizing and synthesizing spoken language, powering tools like voice assistants and transcription systems. Natural language processing is chosen for analyzing and summarizing text, helping systems comprehend and organize large amounts of human language data. Information extraction works to pull structured data from documents or recordings, turning raw content into usable information. And finally, decision support uses historical data and learned patterns to predict outcomes or recommend actions, which is the essence of AI-driven strategic assistance. Question 3. Fill in the blanks by selecting the correct options from the drop-down menus. A multi-service resource groups multiple Azure AI services under one endpoint, simplifying management for solutions that use several capabilities. Now, let's go through the explanation so you understand why these are correct. A multi-service resource is the correct term because it refers to the Azure configuration that consolidates several AI services, like vision, language, and speech, into one manageable unit. This setup simplifies resource creation, permissions, and cost tracking across services. The endpoint is also correct because it provides a single access point for all those bundled services, allowing applications to interact with them seamlessly through one unified URL. Other options like subscription, pipeline, container, or namespace are incorrect since they handle different roles. Subscriptions are for billing, pipelines for workflows, containers for packaging, and namespaces for organizing messaging or Kubernetes resources, none of which simplify AI service bundling in Azure. Question 4. Fill in the blanks by selecting the correct options from the drop-down menus. To ensure accurate, domain-specific answers, an agent can use RAG, which first retrieves relevant grounding data, then augments the prompt with that data, and finally uses a language model to generate a grounded response. Now let's walk through the explanation so you understand how this process works. RAG, short for Retrieval Augmented Generation, is the method used to produce grounded and factual AI responses. It begins by retrieving relevant grounding data. This means the system searches for information aligned with the user's prompt to provide factual context. Then, it augments the prompt by inserting that retrieved data, ensuring the model's next step is based on accurate and updated information. Finally, it uses a language model to generate a grounded response, combining the context with natural language fluency to produce a precise and relevant answer. Other methods like temperature sampling, prompt styling, or fine-tuning alone can adjust style or creativity, but do not guarantee factual grounding the way RAG does. Question 5. For each prompt flow tool type, drag it to the capability it performs in a RAG-enabled flow. Each item may be used once, more than once, or not at all. Transform or compose retrieved documents into a single context string. Python node. Query the search index to fetch relevant passages. Index lookup tool. Create alternative system messages or prompt wordings to compare groundedness. Prompt variants. Submit a composed prompt with context to an LLM to generate an answer. LLM node. Now let's go over the explanation together so it all makes sense. The Python node is matched with transforming or composing documents because it processes and formats retrieved content into one cohesive prompt-ready string, often combining multiple results for context. The index lookup tool is correct for querying the search index, as it retrieves the most relevant passages needed for grounding in the RAG process. Prompt variants are used to generate alternative system messages or prompt structures, helping evaluate which version produces the most accurate or contextually grounded output. Lastly, the LLM node is responsible for sending the composed prompt, complete with context, to the language model and returning the final generated answer. Unused items like the blob trigger and Cosmos DB change feed are not part of this RAG flow, since they relate to storage or data streaming rather than retrieval or generation. Question 6. In the context of evaluating generated outputs, what does precision refer to? Select one answer. A. The proportion of true positive, correct outputs among all generated outputs. B. How often a model retrieves all relevant items, including those it missed previously. C. The average latency per token when generating responses. D. The total GPU memory consumed during a batch inference run. The correct answer is A. The proportion of true positive, correct outputs among all generated outputs. Now let's explain this clearly so you can remember it easily. Precision measures how many of the outputs the model generated were actually correct, focusing on the accuracy of positive results. For instance, if an AI retrieves 10 answers and 8 are correct, its precision is 80%. This helps evaluate how well a system avoids false positives when producing outputs. Option B refers to recall, which measures completeness. How many of the total relevant results were found, not their correctness. Option C, average latency per token, deals with processing speed, not accuracy. And option D, total GPU memory, is a performance or hardware metric, unrelated to the concept of precision in model evaluation. Question 7. For each statement below, indicate whether the answer is true or false. Language models generate responses based entirely on the data used during their training. True. Ungrounded responses are always factually correct because they use general internet data. False. Grounding involves adding relevant factual data to the model's prompt. True. A grounded model's responses are less relevant to the user's query. False. Now, let's go through the explanation clearly and smoothly. The first statement is true because language models depend on patterns and relationships learned from their training data to generate responses. However, they lack inherent awareness of factual correctness. The second statement is false, since ungrounded responses, though they might sound convincing, can include inaccurate or made-up details because they aren't tied to verified data sources. The third statement is true because grounding specifically means enhancing model accuracy by embedding factual, context-relevant information within the prompt. Finally, the fourth statement is false because grounding makes responses more relevant, not less, as it connects directly to the user's query with accurate and contextual data. Question 8. A developer attempts to connect to Azure AI Search in their RAG params but gets an authentication error. Which configuration is required for successful access? Select one answer. A. Provide an authentication object with type API key and the valid key value. B. Add key directly under parameters without an authentication wrapper. C. Omit the authentication field. The SDK automatically handles it. D. Use authentication. Type system identity for all connections by default. The correct answer is A. Provide an authentication object with type API key and the valid key value. Now let's go through the explanation carefully. Azure AI Search requires an explicit authentication object that defines the credential type and key value to authorize access. By using an authentication object with type API key, the developer ensures the connection is properly verified before retrieving any data. Adding a key directly under parameters would fail since the key must be nested within the authentication object. Omitting the authentication field would also cause an error because no credentials would be sent, resulting in access denial. And using system identity is incorrect here, since the default setup relies on the API key method, not managed identity. Therefore, providing the authentication object with type API key and the correct key value is the configuration needed for successful access. Question 9. A support team wants to fine-tune a chat model to sound friendly and concise. They have historic chat logs that include sensitive customer information and some assistant replies they don't want the model to learn from. What should they do to prepare the training data? Select one answer. A. Anonymize sensitive content, format as JSON-L with role labels, and exclude unwanted replies by setting weight equals 0. B. Keep all messages for completeness, then rely on the model to ignore sensitive content. C. Use a CSV with 2 columns, prompt response, so formatting is simpler. D. Keep assistant replies unweighted to avoid biasing the dataset. The correct answer is A. Anonymize sensitive content, format as JSON-L with role labels, and exclude unwanted replies by setting weight equals 0. Now let's go through the explanation clearly. When preparing fine-tuning data, sensitive information must be anonymized before training to protect privacy and prevent leakage of customer data. JSON-L with role labels, system, user, and assistant, is the proper structure because it preserves conversation roles in chat model training. Setting the weight of unwanted assistant replies to 0 ensures that the model ignores those examples during learning, improving dataset quality and control. Option B is incorrect since the model cannot ignore sensitive data on its own. It must be removed before training. Option C is wrong because a simple CSV lacks the structure required for multi-turn chat fine-tuning. And option D is incorrect because weighting allows selective inclusion or exclusion, not bias avoidance. Question 10. Arrange the following mitigation cycle steps in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Determine a baseline and measurement approach. Apply layered mitigations. Retest the modified system. Compare harm levels against the baseline and record results. Now, let's go through the explanation together so it's easy to follow. The first step is to determine a baseline and measurement approach because every mitigation cycle starts by establishing a reference point to assess future changes. Once the baseline is set, the next step is to apply layered mitigations, which means using multiple defensive strategies to reduce risks rather than relying on a single solution. After applying these mitigations, the system must be retested under the same conditions used to create the baseline to see if performance or risk levels have changed. Finally, the harm levels from the new results are compared against the original baseline, and the findings are recorded to evaluate whether the mitigations were effective and to guide the next iteration of improvements. Question 11. Which description correctly defines an endpoint in Azure AI Foundry? Select one answer. A. A script that executes model training steps on a developer's machine. B. A unique URL that provides access to a deployed model or service through an API. C. A container image used for storing model artifacts. D. A diagnostic dashboard for monitoring server health. The correct answer is B. A unique URL that provides access to a deployed model or service through an API. Now let's go through the explanation to make this clear. An endpoint in Azure AI Foundry serves as a unique URL that allows client applications to communicate with a deployed model or service. It acts as the interface where data requests and responses are exchanged programmatically, enabling real-time model inference and integration into other systems. Option A is incorrect because scripts that execute training steps are part of a model's training pipeline, not its deployment. Option C is wrong since container images store model artifacts but do not handle API access. Option D is also incorrect because diagnostic dashboards are for monitoring system performance, not for invoking models. Therefore, an endpoint is best defined as the unique API-accessible URL for interacting with deployed AI services. Question 12. Your team has completed experimentation on a custom AI workflow and is preparing to move it into production in Azure AI Studio. Which two actions are most relevant during the production phase? Select two answers. A. Run rapid iterations to refine the prompt and flow design. B. Optimize the flow for efficiency and effectiveness before deployment. C. Deploy the flow to an endpoint so client applications can invoke it. D. Define initial categories and gather a small sample dataset. The correct answers are B. Optimize the flow for efficiency and effectiveness before deployment, and C. Deploy the flow to an endpoint so client applications can invoke it. Now let's go over the explanation together. During the production phase, the primary focus is to make the workflow efficient, scalable, and ready for real-world use. Optimizing the flow ensures it performs reliably and efficiently under production conditions, minimizing latency and maximizing accuracy. Deploying it to an endpoint operationalizes the solution, allowing external applications to trigger and consume the AI workflow through a stable API connection. Option A is incorrect because running rapid iterations belongs to the experimentation phase, where designs and prompts are tested and refined. Option D is also incorrect, since defining categories and gathering small sample data happens in the initialization stage, before experimentation even begins. Question 13. Your team submits a fine-tuning job in Azure AI Foundry. You did not include a validation dataset, but need to assess quality quickly once training completes. What's the most appropriate next step? Select one answer. A. Deploy the fine-tuned model and run targeted tests against representative chat prompts. B. Resubmit the job with double the batch size to get better results automatically. C. Assume quality is acceptable because training finished successfully. D. Increase the learning rate multiplier to 0.5 and skip testing. The correct answer is A. Deploy the fine-tuned model and run targeted tests against representative chat prompts. Now let's go over the reasoning so it's clear. When a validation dataset isn't provided, deploying the fine-tuned model and testing it against selected representative prompts is the best way to evaluate its behavior and quality. This hands-on testing helps verify how well the model performs on realistic inputs, ensuring it meets expected standards before full release. Option B is incorrect because adjusting hyperparameters like batch size doesn't replace proper evaluation and may not guarantee improvement. Option C is wrong, since training completion doesn't mean the model is accurate or reliable without validation. Option D is also incorrect because increasing the learning rate multiplier can cause instability and poor results, and testing remains essential either way. Question 14. Fill in the blanks by selecting the correct options from the drop-down menus. When a user submits a question to an expense agent, the agent uses a knowledge store to ground the query, passes it to a language model, and then generates both a response and an expense claim for processing. Now let's go through the explanation step by step. The knowledge store is chosen because it provides relevant and structured policy data that helps the agent ground the user's query with factual information. Next, the language model is used to interpret that grounded input and generate a coherent, natural language answer. From there, the agent produces a response for the employee, while simultaneously generating an expense claim for automated processing. Options like a policy approval form or manual review are incorrect because the system operates through structured automation, not human intervention. Similarly, a chatbot interface alone doesn't describe the full process, since grounding and automation occur beyond simple conversation. Question 15. Fill in the blanks by selecting the correct options from the drop-down menus. Previous approaches often required hundreds of lines of code to wire up function calling and grounding, whereas Foundry Agent Service supports client-side function calling with just a few lines and can connect to Azure Functions or an OpenAPI spec tool. Now I'll explain why each choice fits. First, hundreds of lines of code captures the heavy lift in earlier patterns, where developers hand-wired prompts, tools, and grounding glue. Next, client-side function calling is correct because Foundry Agent Service lets you invoke tools with minimal code from the client, reducing orchestration complexity dramatically. Then, Azure Functions is appropriate since it's a supported action tool for serverless execution that agents can call directly. Finally, OpenAPI spec is valid because agents can call external APIs described by OpenAPI 3.0, enabling quick integrations without custom wrappers. Question 16. For each statement below, indicate whether it is true or false. The Microsoft Agent Framework allows integration with multiple AI providers without changing application code. True. The Azure AI Foundry agent manages conversation history using secure thread storage. True. The chat agent type is designed only for data analysis tasks. False. The Anthropic agent provides access to Claude models using the same interface as other agents. True. Now let's go through the explanation to understand why each one is correct. The first statement is true because the Microsoft Agent Framework is provider agnostic, meaning developers can switch between services like OpenAI, Azure OpenAI, or Anthropic without rewriting application code. The second statement is also true since Azure AI Foundry agents use secure thread-based storage to maintain conversation history and context efficiently. The third statement is false because the chat agent type supports broad conversational and task completion scenarios, not just data analysis. Finally, the fourth statement is true because the Anthropic agent connects to Claude models through the same unified interface as other providers, maintaining consistency and ease of integration across platforms. Question 17. For each agent executor concept, drag it to its correct definition in the table below. Each item may be used once, more than once, or not at all. Handles incoming requests and generates responses. Execute. Processes cancellation of ongoing tasks. Cancel. Provides access to incoming request details. Request context. Sends messages or updates back to clients. Event queue. Now I'll explain so the flow is crystal clear. First, execute is correct because it runs the agent's logic, processes the request, and produces the response, which is the executor's primary job. Next, cancel fits the second row since cancellation handling stops or rolls back work when a client withdraws a task, provided the agent supports it. Meanwhile, request context holds the request's metadata, parameters, and state, enabling the executor to understand what to do and how to do it. Finally, event queue is right for sending updates or final results back to the requester because it is the channel through which events and messages are emitted to clients. Question 18. For each type of agent request, drag it to its correct description. Each item may be used once, more than once, or not at all. Sends a message and waits for a complete response. Non-streaming request. Sends a message and receives incremental updates. Streaming request. Useful for simple single-response interactions. Non-streaming request. Suitable for long-running tasks or real-time updates. Streaming request. Now let's explain this together. A non-streaming request is used when a client expects one full response. The agent processes everything first and then returns the final result, which makes it perfect for short, direct interactions like fetching a record or answering a simple question. On the other hand, a streaming request sends results in chunks, offering updates as the task progresses. This makes it very useful for longer or real-time activities, such as summarizing large documents or tracking continuous data streams. In short, non-streaming requests are best for quick tasks with a single reply, while streaming requests shine in dynamic situations where you need to see progress as it happens. Question 19. A financial services company wants to ensure private customer data is handled by a dedicated component that operates independently, while still automating workflows without custom orchestration. Which approach should they adopt? Select one answer. A. Expand a single general-purpose agent to include privacy and routing features. B. Use connected agents where a main agent delegates to a privacy-focused subagent. C. Write custom routing scripts to send private data to the correct service. D. Assign sensitive data processing to the main agent only, avoiding delegation. The correct answer is B. Use connected agents where a main agent delegates to a privacy-focused subagent. Now let's go through the explanation together. The use of connected agents allows one main agent to hand off specific responsibilities to specialized subagents. In this case, a privacy-focused subagent can handle sensitive customer information independently, ensuring security and compliance while the main agent coordinates the workflow. This approach avoids the need for custom orchestration logic and keeps the design modular and maintainable. Expanding one general-purpose agent or assigning all responsibilities to a single component would make the system harder to manage and increase risk. Likewise, writing custom routing scripts would complicate automation rather than simplify it. Therefore, using connected agents with clear delegation ensures privacy, efficiency, and scalability all at once. Question 20. For each statement below, indicate whether the answer is true or false. Connected agents help improve accuracy by giving tasks to specialized roles. True. Using a single agent is always easier to maintain than multiple connected agents. False. Subagents can be reused across multiple solutions to save development effort. True. Custom orchestration is required when connecting multiple agents together. False. Now let's go through the explanation step by step. Connected agents improve accuracy because each subagent can focus on a specialized role, leading to better precision within its domain. For instance, one agent might handle privacy, while another manages financial logic, ensuring both operate at their best. Next, using a single agent might seem simpler, but as workflows grow, that single agent becomes harder to manage. Multiple connected agents, on the other hand, make the system easier to maintain and scale over time. Moreover, subagents can be reused across different projects, saving both time and development effort. This modularity enhances consistency and speeds up solution building. Finally, there's no need for custom orchestration when connecting multiple agents. Delegation between agents is handled automatically within the framework, making the process efficient and seamless. Question 21. A team wants to build a solution where the user only interacts with one central agent, but that agent should be able to retrieve stock prices, summarize documents, and validate compliance by delegating tasks. What is the best way to design this solution? Select one answer. A. Create a single main agent with all functionality hard-coded. B. Create specialized connected agents for each task, register them as tools, and configure the main agent to delegate. C. Implement a workflow engine that manually routes user requests to different scripts. D. Design multiple main agents so each user request is handled independently. The correct answer is B. Create specialized connected agents for each task, register them as tools, and configure the main agent to delegate. Now I will explain why this is correct. First, delegating to connected subagents lets each role specialize. So a market data agent fetches stock prices accurately, a summarizer condenses documents, and a compliance agent checks policies, which collectively improves quality and reliability. Next, this setup remains modular and reusable because each subagent can be updated or swapped without touching the central experience the user sees. Moreover, it removes the need for a custom workflow engine, since the main agent naturally routes requests to the registered tools and aggregates results. Conversely, hard-coding everything into one agent becomes brittle and hard to maintain as features grow, and multiple main agents would fragment context and confuse routing. Therefore, configuring a single orchestrating agent with connected task-focused sub-agents delivers a scalable, maintainable, and user-friendly design. Question 22. Arrange the following steps required to create an Azure AI Foundry agent in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. 1. Create an Azure AI Foundry project. 2. Add the connection string to the Microsoft Agent Framework code. 3. Set up authentication credentials. 4. Create a chat agent with Azure AI Agent Client. 5. Define tools and instructions for the agent. Now let's go through the explanation together. To build an Azure AI Foundry agent, you start by creating a Foundry project. This establishes the workspace that hosts and manages your agent. Next, you link your application to that project by adding its connection string to the Microsoft Agent Framework code, which creates the bridge between your code and Azure AI services. After that, you set up authentication credentials to ensure secure communication and proper access permissions. Once everything is securely connected, you create the chat agent instance using Azure AI Agent Client. This step initializes your agent within the configured environment. Finally, you define tools and instructions for the agent, specifying what capabilities it has and how it should behave. In short, this sequence builds a fully functional and secure Azure AI Foundry agent from setup to deployment. Question 23. A company wants to extend its AI agent's functionality to automatically retrieve data from an external weather API when users ask for weather updates. Which feature enables this integration without requiring manual API calls? Select one answer. A. Manual scripting through Azure Functions. B. Tools integration within the Microsoft Agent Framework. C. Agent thread for maintaining conversation history. D. Azure AI Agent Client for connecting to the Foundry project. The correct answer is B. Tools integration within the Microsoft Agent Framework. Now let's go through the explanation step by step. Tools integration within the Microsoft Agent Framework allows developers to register external functions that the AI agent can call automatically whenever needed. This means when a user requests a weather update, the agent can instantly invoke the registered API without needing manual scripts or code intervention. In contrast, manual scripting through Azure Functions would require custom development, which defeats the purpose of automation. Agent thread is used for conversation management, not for connecting to external APIs. Likewise, Azure AI Agent Client only manages the connection to Azure AI Foundry. It doesn't handle data retrieval from third-party sources. Therefore, tools integration is the key feature that makes external service communication seamless and automatic within the agent framework. Question 24. Which two features distinguish AI agents from traditional generative AI chat models? Select two answers. A. Generative AI chat models provide the same autonomous decision-making as AI agents. B. AI agents can autonomously use decision-making algorithms and ML models to act on data. C. AI agents can execute complex workflows independently. D. Generative AI chat models can schedule sales calls. The correct answers are B. AI agents can autonomously use decision-making algorithms and ML models to act on data, and C. AI agents can execute complex workflows independently. Now let's explain why this is correct. AI agents go far beyond generating text. They can make informed decisions by applying algorithms and machine learning models to real data. This enables them to analyze patterns, evaluate outcomes, and act without needing constant human supervision. For instance, an AI agent could monitor stock performance, detect trends, and automatically execute transactions based on preset rules. Furthermore, AI agents are capable of running entire workflows on their own. Unlike chat models that simply respond to prompts, agents can handle multi-step operations such as gathering data, verifying inputs, and completing tasks end-to-end. For example, an AI agent in customer service might escalate a ticket, send an email, and log the resolution automatically. In contrast, generative AI chat models are limited to producing conversational text. They don't possess true autonomy or workflow execution abilities. Hence, what sets AI agents apart is their decision-making power and their ability to operate independently across complex processes. Question 25. Which challenge does an MCP server directly address when connecting tools to AI agents? Select one answer. A. Preventing the model from generating text responses. B. Reducing the complexity of manually integrating and maintaining external tools. C. Guaranteeing unlimited computational resources for agents, removing the need for APIs entirely. The correct answer is B. Reducing the complexity of manually integrating and maintaining external tools. Now let's move into the explanation. An MCP server simplifies the process of connecting external tools to AI agents by centralizing and automating tool discovery. Normally, developers would have to manually configure and maintain integrations between multiple APIs and systems, which can become complicated and error-prone. MCP eliminates this by handling tool registration and management automatically, making it far easier to connect agents to new capabilities. On the other hand, it does not prevent the model from generating text responses. That's outside its function. It also doesn't guarantee unlimited computing resources, since resource management is handled at the infrastructure level. And while it connects through APIs, it doesn't remove them. It simply streamlines their use. In summary, MCP servers reduce the complexity and maintenance effort of integrating and managing external tools for AI agents, allowing developers to focus on building smarter and more capable systems. Question 26. What are two key elements typically included in an agent card? Select two answers. A. Agent's endpoint URL. B. Model training dataset. C. Authentication support. D. Debugging scripts. The correct answers are A. Agent's endpoint URL and C. Authentication support. Now let's explain why these two are correct. An agent card serves as the profile of an AI agent, defining how other agents or systems can connect and communicate with it. The agent's endpoint URL identifies the exact address where the agent's service can be accessed. This is essential for enabling secure, structured communication between agents in an A2A, agent-to-agent environment. Next, authentication support specifies the security requirements for interacting with the agent, such as whether credentials or tokens are needed. This ensures that sensitive data and system access are protected while allowing legitimate integrations to proceed smoothly. On the other hand, model training dataset is unrelated. It belongs to the model development phase, not the operational description of an agent. Similarly, debugging scripts are developer tools used for troubleshooting, not part of the agent card's metadata. Therefore, the two key elements of an agent card are the agent's endpoint URL and authentication support, as they define how and under what conditions the agent can be securely accessed. Question 27. Which statement best describes how an agent executor communicates results back to a client or another agent? Select one answer. A. It uses a communication channel that can stream continuous updates or send individual messages. B. It always stores results locally and never sends them back to the requester. C. It relies on the routing agent to execute and send all responses. D. It can only send responses after all agents finish their work. The correct answer is A. It uses a communication channel that can stream continuous updates or send individual messages. Now let's go over the explanation. The agent executor acts as the active component responsible for processing requests and returning results. It communicates through a dedicated channel that supports both continuous streaming and discrete message updates. This means that as tasks are being executed, results can be sent in real time, just like receiving live progress updates during a download or a data analysis session. This streaming mechanism allows for responsive feedback, especially in long-running or complex operations. Instead of waiting until everything is done, the executor can deliver insights or partial outputs as they're ready. Conversely, the executor does not store results locally, nor does it depend on a routing agent to send them. It also doesn't wait for all agents to finish their work, since its communication process is dynamic and adaptive. So, the key takeaway is that an agent executor uses a communication channel designed to handle both real-time streaming and individual message delivery, ensuring timely and flexible feedback during execution. Question 28. Fill in the blanks by selecting the correct options from the drop-down menus. A REST request to a knowledge base includes a question to be answered, a top value that specifies how many answers to return, and a score threshold that filters answers below a certain confidence level. Now, let's go through the explanation. When you make a REST request to a knowledge base, the question field represents the user's query. It defines what the API should attempt to answer. This is the core of the request body, as it tells the service exactly what information is being sought. Next, the top parameter specifies the maximum number of answers the system should return. For example, setting top 3 tells the API to send back the 3 best matching answers ranked by confidence. Finally, the score threshold parameter acts as a quality filter. It ensures that only responses with a confidence score higher than the specified threshold are included, effectively filtering out low-quality or uncertain results. Meanwhile, other options like confidence score or endpoint are not part of the request structure. Confidence score appears only in the response, and endpoint refers to the API location itself, not a JSON property. So in summary, the correct combination is question, top, and score threshold, which together define what to ask, how many answers to retrieve, and the confidence level required for inclusion. Question 29. For each Azure AI language service capability, drag it to the appropriate description in the correct match column. Each item may be used once, more than once, or not at all. Extracts and identifies entities such as people, places, or companies. Named entity recognition. Detects and redacts sensitive data like email addresses or IP addresses. PII detection. Determines the overall emotional tone of text. Sentiment analysis. Identifies the language used in text documents. Language detection. Summarizes large bodies of text or conversation into key sentences. Summarization. Extracts key ideas or concepts from input text. Key phrase extraction. Now let's explain why each match is correct. Named entity recognition is responsible for identifying names of people, locations, or organizations in text. This helps systems understand meaningful entities within large datasets, for example, recognizing Microsoft as a company or Paris as a location. PII detection focuses on finding and masking personally identifiable information like phone numbers or credit card details. This is essential for data privacy and compliance in industries like finance and healthcare. Next, sentiment analysis determines whether text expresses positive, negative, or neutral emotions. It's widely used for analyzing customer feedback or social media comments to gauge public perception. Language detection identifies which language a document or message is written in. For instance, detecting whether a sentence like "Bonjour tout le monde" is French. Then, summarization condenses long documents or transcripts into concise summaries, keeping only the key points. This is useful for processing lengthy reports or meeting transcripts efficiently. Finally, key phrase extraction identifies central ideas or recurring concepts in text, such as extracting Azure AI services or data security as key terms in a technical article. Therefore, the correct matches are named entity recognition, PII detection, sentiment analysis, language detection, summarization, and key phrase extraction. Question 30. Fill in the blanks by selecting the correct options from the drop-down menus. When building the request to classify text, the property display name gives a friendly job name. The property analysis input contains the text documents, and the property tasks specifies which model and deployment should be used. Now let's go over the explanation. The display name property is primarily used to assign a human-readable name to the classification job. This makes it easy to track or log the job later, especially when multiple analyses are running concurrently. Next, the analysis input property serves as the container for the documents array. In other words, it holds the actual text content that will be analyzed. For instance, if you're classifying customer feedback, This property includes the text entries being sent for processing. Finally, the tasks property defines the operations that need to be executed. It lists the model and deployment configurations, ensuring that the correct classification model is applied to the text. Other terms like metadata, model label, or project kind do not apply here. They relate to project definitions, model training, or configuration categories rather than runtime classification tasks. So the correct answer is display name, analysis input, and tasks, each serving a unique role in setting up and executing the classification request efficiently. Question 31. For each model evaluation metric, drag it to the correct description in the table below. Each item may be used once, more than once, or not at all. The ratio of successful entity recognitions to all attempted recognitions. Precision, the ratio of successful entity recognitions to the actual number of entities in the document. Recall, the combination of precision and recall into a single metric, F1 score. Now, let's explain how each metric works and why it fits its definition. Precision measures how accurate the model's positive predictions are. In other words, it checks how many of the entities the model identified were actually correct. A higher precision means fewer false positives. For example, when a model labels Microsoft as a company, it's likely right most of the time. Recall evaluates the model's ability to find all relevant entities. It tells us how many of the actual entities in the text were successfully detected. If a document mentions 5 company names and the model correctly finds 4, recall would be 80%. F1 score serves as a balance between precision and recall. It's the harmonic mean of both, giving a single number that represents overall model performance. This is useful because a model could have high precision but low recall, and the F1 score helps capture that trade-off in one value. Meanwhile, accuracy and confidence level are not used in this specific context. Accuracy measures overall correctness in classification tasks, and confidence level refers to prediction certainty rather than evaluation quality. So, the correct answers are precision, recall, and F1 score, each representing a critical way of evaluating model recognition performance. Question 32. Fill in the blanks by selecting the correct options from the drop-down menus. Speech synthesis customization in Azure AI. Speech uses a speech config object to set both audio format and voice name before generating speech. Now let's go over the explanation. The speech config object serves as the foundation for configuring text-to-speech settings. It defines key parameters that control how speech is generated, including what voice is used and how the output audio is formatted. This object ensures consistency across different speech synthesis tasks. Next, the audio format defines the technical properties of the audio output, for example, the sample rate, bit depth, or file type. This determines whether the speech output is optimized for scenarios like streaming or playback on specific devices. Meanwhile, the voice name specifies the accent, tone, and style of the synthesized speech. For instance, you might select NUS Jenny Neural for a natural American female voice, or NGB Ryan Neural for a British male voice. This customization allows developers to tailor the user experience to specific regions or brand personalities. Other properties, such as audio stream, recognition config, or speech model, are not applicable here because they relate to speech recognition or data output rather than the configuration of synthesized audio. Therefore, the correct configuration involves using the speech config object to set both audio format and voice name before generating the final speech output. Question 33. For each statement below, indicate whether it is true or false. Mixed language input within a single document returns the predominant language with a typically lower confidence score. True, if the analyzer cannot interpret text, for example, due to encoding issues, it may return unknown for the language with a 0.0 confidence score. True. Language detection requires full documents. Single phrases are not supported. False. The response from the Language Detection API can include a warnings array that provides contextual messages about the detection process. True. Now let's go through the explanation. When the input contains mixed languages, the language detection service analyzes the text and selects the most dominant or frequently used language. However, because multiple languages appear in the same document, the model's confidence in that prediction is usually lower than if the text were entirely in one language. Next, if the analyzer encounters text that it cannot interpret, perhaps due to invalid encoding or unreadable characters, it returns unknown as the language name with a confidence score of 0.0, indicating that the system could not identify any valid language. Third, language detection does not require full documents to work. The system can successfully analyze shorter text snippets or single phrases, although smaller samples might produce slightly lower confidence levels. Hence, the statement that single phrases are not supported is false. Finally, the language detection API includes a warnings array within the response object. This provides additional details about the detection process, such as truncated input or low confidence conditions, even when detection completes successfully. So, the correct responses are true, true, false, true, reflecting how Azure AI language detection handles mixed input, unknown cases, flexible input sizes, and contextual warnings. Question 34. A company wants its virtual assistant to answer specific FAQs like, what are your store hours? And also perform actions such as book me a meeting with HR. Which approach should they use to achieve this? Select one answer. A. Combine question answering and language understanding. B. Use only question answering for all tasks. C. Rely solely on language understanding. D. Deploy Azure OpenAI service to handle both scenarios. Correct answer? A. Combine question answering and language understanding. Now let's explain. Question answering is optimized to fetch precise pre-authored answers from a knowledge base. Therefore, it excels at FAQs like store hours or return policies. Meanwhile, language understanding detects intents and entities, so it can recognize requests such as book with HR and tomorrow at 10, then pass those details to an action workflow. Consequently, using both together gives you factual responses and task execution in one assistant. By contrast, only question answering cannot infer or trigger actions, and only language understanding does not provide curated FAQ answers. Likewise, Azure OpenAI alone can generate text, yet it doesn't supply structured intent handling or guaranteed knowledge-based answers. For example, the bot can answer, "We're open 9 to 6 instantly. Then, in the same chat, schedule a meeting with HR using the detected intent and time details. Question 35. Arrange the following steps for validating and publishing a knowledge base in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Train the natural language model. Test the knowledge base using sample questions. Review confidence scores and alternative answers. Deploy the knowledge base to a REST endpoint. Now let's explain. To validate and publish a knowledge base, the first step is to train the natural language model, because this enables it to interpret and respond to user queries accurately based on curated data. After training, the next step is to test the knowledge base using sample questions to measure how well it retrieves the correct answers. Then, you review confidence scores and any alternative answers to gauge reliability and pinpoint where the model might need adjustment. Finally, once accuracy and consistency meet expectations, you deploy the knowledge base to a REST endpoint, making it accessible for integration with applications and chat systems. This logical progression ensures the knowledge base performs effectively before going live. Question 36. A developer is examining 2 JSON payloads for Azure AI language projects. In one payload, each document contains a single class object, while in the other, each document contains a classes array with multiple entries. What can be concluded about these 2 projects? Select one answer. A. Both payloads represent the same project type because class and classes are interchangeable. B. The first payload represents a single label classification project, and the second represents a multi-label classification project. C. The second payload represents a regression project predicting numeric outcomes. D. Both payloads define clustering tasks without predefined labels. Correct answer, B. The first payload represents a single label classification project, and the second represents a multi-label classification project. Now let's explain. In Azure AI language, a single label classification project assigns exactly one label to each document, which is why the payload contains a single class object. In contrast, a multi-label classification project allows a document to belong to more than one category, so its payload includes a classes array holding multiple labels. These two types differ fundamentally in how they handle document categorization. The class field is not interchangeable with classes, because the structure itself determines the classification approach. For instance, a product review might be labeled only positive in a single label model, but in a multi-label scenario, it could be tagged as both positive and about delivery to capture multiple aspects of meaning. Question 37. For each statement below, indicate whether it is true or false. The training status and evaluation status fields indicate progress of the training job. True. A training job must be checked periodically until the status changes to succeeded. True. The REST API response body for training always returns final results immediately. False. The response code 202 means the operation has finished successfully. False. Now let's explain. The training status and evaluation status fields track the progress of model training and evaluation, showing whether the job is running, succeeded, or failed. Because training is asynchronous, you need to check its status periodically until it changes to succeeded. The REST API doesn't return final results instantly. Instead, it gives a status endpoint that you can pull to monitor progress. Finally, the response code 202 simply means the request has been accepted and is still processing. It does not indicate completion. This ensures that long-running training jobs can be monitored efficiently without blocking other operations. Question 38. During the setup of a question answering solution, after defining and populating the knowledge base, what additional actions are required before it can be used by applications? Select one answer. A. Add more virtual networks. B. Recreate the Azure subscription. C. Export the data to Excel. D. Train and publish the knowledge base. The correct answer is D. Train and publish the knowledge base. Now let's explain. After defining and filling a knowledge base with data, it isn't immediately ready for use by client applications. It first needs to be trained so the system can process the new content, learn from the questions and answers, and ensure that the model understands the relationships between them. Once the training is complete, publishing makes the knowledge base accessible through its endpoint, allowing client apps to query it effectively. For example, if you're creating a support chatbot using Azure AI question answering, the bot can only start responding accurately after the knowledge base has been trained and published. Therefore, adding networks or exporting data doesn't play a role here. The essential step is to train and publish the knowledge base before deployment. Question 39. A game studio is building a classifier over short game summaries. Early tests show many summaries tagged as strategy are not being predicted as strategy, while some summaries predicted as strategy are actually labeled only action. The team wants a single metric to balance the trade-off between identifying more strategy documents and keeping false strategy predictions low. Select one answer. A. Focusing on recall alone is sufficient to optimize both concerns. B. Use F1 score as the target to balance precision and recall. C. Increase the number of labels and convert the project to multiple label classification. D. Replace evaluation with manual spot checks to capture nuance. The correct answer is B. Use F1 score as the target to balance precision and recall. Let's move on to the explanation. The F1 score is a harmonic mean of precision and recall, making it the most appropriate metric when you need to balance both false positives and false negatives. In this scenario, the model struggles to correctly identify all strategy summaries while avoiding incorrect strategy classifications. By optimizing for F1 score, the team ensures that both aspects, capturing all true strategy cases, recall, and avoiding misclassifications, precision, are considered equally. Metrics like recall alone would overemphasize identifying more strategy summaries but could increase false positives. Therefore, the F1 score provides a balanced and reliable measure of overall model performance. Question 40. In the REST API JSON for Azure AI language classification, which field specifies the natural language used within a document? Select one answer. A. Project kind. B. Language. C. Dataset. D, storage input container name. The correct answer is B, language. Now let's explain. In the REST API JSON structure, the language field identifies the human language of the text being analyzed, such as N for English or FAR for French. This specification enables Azure AI language to correctly process multilingual documents and apply the proper linguistic models for classification. For example, if you submit documents written in both English and Spanish without specifying their language, the model might misinterpret syntax or vocabulary, leading to incorrect classifications. By clearly defining the language field, the system ensures that the correct language-specific tokenization and analysis pipelines are used. Meanwhile, project kind only defines the project type, not the document's language. Dataset groups files for training or testing, but doesn't specify the language used. And storage input container name merely points to where the data is stored, not its linguistic attributes. Therefore, the field that correctly specifies the natural language of a document is language. Question 41. What is the maximum number of deployment names allowed per Azure AI language project? Select one answer. A, 5, B, C, unlimited, D. The correct answer is A, 10. Now let's explain. Each Azure AI language project supports up to 10 distinct deployment names. This means developers can create up to 10 different versions or configurations of their models under the same project, allowing flexibility for testing and production environments. For example, one deployment could be used for internal testing, while another could serve live customer requests, both operating independently within the same project. Meanwhile, 5 would be too few since the actual system limit is higher. Unlimited is incorrect because Azure enforces defined limits to manage resources and prevent overallocation. And 1 is also wrong since multiple deployments can coexist simultaneously for scalability and experimentation. Therefore, the maximum number of deployment names per Azure AI language project is 10. Question 42. A team is developing a voice-enabled chatbot for customer service. The application must process customer voice messages and generate natural language responses. The team plans to deploy a model that supports both text and audio inputs within Azure AI Foundry. The team should deploy which of the following? Select one answer. A, OpenAI GPT 3.5 Turbo. B, Microsoft 5.4 Multimodal Instruct. C, Azure Speech-to-Text. D, Text-Only GPT model. The correct answer is B, Microsoft 5.4 Multimodal Instruct. Now let's explain. Microsoft 5.4 Multimodal Instruct is the right choice because it supports both audio and text inputs, allowing chatbots to understand spoken commands and respond naturally. This capability makes it ideal for building voice-enabled customer service assistants that need to interpret speech and provide intelligent responses. On the other hand, OpenAI GPT 3.5 Turbo handles only text-based input and cannot process audio, limiting its use in voice applications. Azure Speech-to-Text, while capable of transcribing audio to text, does not generate conversational responses, making it insufficient for chatbot deployment. Finally, text-only GPT models lack the multimodal support required to process audio inputs, restricting them to text interactions only. Therefore, the best option for a chatbot that must process both spoken and written input is Microsoft 5.4 Multimodal Instruct. Question 43. Which statement accurately describes the question answering feature in Azure AI language? Select one answer. A, it is a translation model that converts utterances into other languages. B, it is a generative model that creates new answers instead of using stored responses. C, it is a type of language model designed to match natural language questions to predefined answers. D, it is a data indexing tool that supports keyword-based search only. The correct answer is C. It is a type of language model designed to match natural language questions to predefined answers. Now let's explain. The question answering feature in Azure AI language is built to interpret natural language questions and return the most relevant stored responses. It does this by understanding the meaning behind the query rather than simply relying on exact keywords. This makes it effective for conversational systems like chatbots or FAQ-based solutions where users might phrase questions in multiple ways. On the other hand, translation models only convert text between languages, not retrieve answers. Generative models create new text outputs instead of pulling from existing knowledge bases, which is not how Azure's question answering works. Finally, data indexing tools depend on keyword matching and lack the semantic understanding required for natural language processing. Therefore, the most accurate description is that it is a language model designed to match natural language questions to predefined answers. Question 44. Which activity specifically makes a trained model callable by client applications? Select one answer. A. Review predictions from user traffic. B. Deploy or publish to a public endpoint. C. Train on additional sample utterances. D. Test with a dataset that has known labels. The correct answer is B. Deploy or publish to a public endpoint. Now let's explain. When a model is trained, it exists internally within the environment and cannot yet be accessed by applications. To make it callable by external clients or services, it must be deployed or published to a public endpoint. This deployment step exposes an API endpoint that allows applications to send real-time data for predictions. On the other hand, reviewing predictions from user traffic is simply part of performance monitoring and doesn't expose the model. Training involves generating the model's parameters, but doesn't make it available for use. Similarly, testing validates performance using sample data, but the model remains inaccessible to clients until it's deployed. Therefore, the key step that makes a trained model callable by client applications is deploying or publishing it to a public endpoint. Question 45. When defining documents in the Azure AI Language REST payload, which field determines whether a document is used for model training or for evaluating predictions? Select one answer. A. Storage input container name. B. Project kind. C. Dataset. D. Metadata.language. The correct answer is C. Dataset. Now here's why. The dataset field indicates whether a document is part of the training or testing subset. This allows Azure AI to know which data should be used to teach the model and which should be used to assess its accuracy. Essentially, it helps maintain a balance between learning and evaluation. Meanwhile, project kind defines the type of classification project, but not the data's role. Storage input container name specifies where files are stored, but doesn't affect training. And metadata.language identifies the document's language, not its dataset purpose. And therefore, the correct field that determines document usage is dataset. Question 46. You are fine-tuning a custom entity recognition model. After reviewing the scores in the View Model Details page of Language Studio, you notice that one entity type has a high precision score, but the model's overall performance score remains low. What does this indicate? Select one answer. A. The model performs equally well for all entities. B. The high-performing entity does not compensate for other low-scoring entities. C. The precision score is incorrectly calculated. D. The model only recognizes entities when they appear multiple times. The correct answer is B. The high-performing entity does not compensate for other low-scoring entities. To understand this better, when fine-tuning an entity recognition model, each entity type is evaluated separately. Even if one entity achieves a high-precision score, the overall model performance depends on how well all entities perform collectively. So, if other entities have poor precision or recall, they drag down the total performance. Meanwhile, saying that the model performs equally for all entities would be incorrect because the scores clearly show variation across entities. The precision score itself is accurate. It simply reflects this uneven performance. And the model's ability to recognize entities isn't tied to how often they appear. In summary, a strong performing entity cannot make up for weak ones, which is why the overall score remains low. Question 47. For each OCR response element, drag it to the appropriate box in the correct match column so it aligns with its definition. Each item may be used once, more than once, or not at all. top-level container that groups recognized text results, read result.blocks, sequence of text with its own bounding polygon and full line string, lines, smallest recognized token with bounding polygon and confidence score, words. Now, let's go over the explanation. In the OCR response, readResult.blocks acts as the highest level grouping, containing one or more lines of recognized text. Meanwhile, lines represent a continuous sequence of words, each carrying a bounding polygon and the complete line's text. On the other hand, words refer to the smallest recognized elements, each with its own text value, bounding polygon, and a confidence score indicating how certain the system is about that recognition. As for the unused items, smart crops deal with area of interest Hurst crops and are not part of OCR structure. Similarly, dense captions belong to region-level captioning and are not used in the OCR read-response framework. Question 48. Arrange the hierarchy of OCR result granularity in the correct order from the largest grouping to the smallest unit. Instruction: drag and drop the items into the correct order, starting with the highest level container at the top. The correct order is blocks, lines, and words. Now let's understand this arrangement more clearly. In an OCR response, blocks serve as the highest level containers, grouping together multiple lines of recognized text. Each line within a block represents a continuous sequence of text, preserving the structure and layout of the document. Finally, words are the smallest elements, representing individual recognized tokens that include their bounding polygons and confidence scores. This hierarchy allows flexible parsing depending on the required detail. For example, entire lines are useful for maintaining document layout, while individual words are essential for fine-grained analysis, such as confidence evaluation or coordinate-based text mapping. Question 49. Fill in the blanks by selecting the correct options from the drop-down menus. The Face API includes operations for verify, identify, and find similar. The verify operation checks if two detected faces belong to the same person, while find similar ranks faces that resemble a given face without requiring identity data. Now let's go over the explanation. The verify operation determines whether two detected faces are of the same individual, which is useful for identity confirmation in authentication systems. Meanwhile, identify searches a database of known faces to find the matching person, such as identifying employees in an organization. Finally, find similar looks for faces that closely resemble a given one, but without needing identity information. This is commonly used in media tagging or photo management applications. Together, these three, verify, identify, and find similar, form the core recognition operations of the Face API, each serving a distinct but complementary role in facial recognition workflows. Question 50. For each statement below, indicate whether the answer is true or false. Facial data should be considered sensitive and private. True. It's sufficient to protect facial data only during model training. Inferencing rarely needs safeguards. False. Transparency includes telling users who will have access to their facial data. True. Fairness means it is acceptable to design features that single out people based on appearance for special scrutiny. False. Now let's understand these statements more clearly. Facial data is personally identifiable information, meaning it directly ties to an individual's identity and must be protected as private and sensitive. However, it isn't enough to secure data only during training. Proper safeguards must also be maintained during inferencing to prevent misuse or unintended exposure. Additionally, transparency means organizations must clearly explain both how facial data is used and who has access to it, ensuring users remain informed and in control. Finally, fairness requires avoiding any design that promotes discrimination or bias. Systems should never single out individuals based on physical appearance for differential treatment or extra scrutiny. Question 51. A marketing team wants to quickly create unique banner images for seasonal campaigns by describing them in plain English. They plan to build a small application using Azure AI Foundry. Which approach best meets their goal? Select one answer. A. Use an image generation model such as DALL-E 3 to produce graphics from natural language prompts. B. Store all banners in Azure Blob Storage and retrieve one at random for each campaign. C. Deploy a speech-to-text model to transcribe campaign slogans. D. Use an image search API to find pictures similar to the text description. The correct answer is A. Use an image generation model such as DALL-E 3 to produce graphics from natural language prompts. Now, here's why this is the best choice. Image generation models like DALL-E 3 can create brand new, original visuals directly from text prompts, which is perfect for marketing teams that need fresh, customized campaign graphics quickly. Unlike storing images in Azure Blob Storage, which only retrieves existing files, DALL-E generates new ones from descriptions. Similarly, speech-to-text models only convert spoken words into text and cannot produce imagery. And while an image search API can find similar pictures, it doesn't create new, unique visuals tailored to a campaign. Therefore, using an image generation model enables automated, creative, and scalable production of banners for dynamic marketing needs. Question 52. When using key-based authentication in a production application that calls Azure AI Vision, where should the authorization key be stored to reduce exposure risk? Select one answer. A. Inside application source code. B. In a local text file on each VM. C. In Azure Key Vault. D. As a hard-coded environment variable on containers. The correct answer is C. In Azure Key Vault. Here's the explanation. Azure Key Vault is designed to securely store secrets, keys, and certificates while supporting access control and key rotation. This ensures that credentials are protected from unauthorized access and can be managed centrally across environments. On the other hand, embedding keys inside source code exposes them to anyone with access to the codebase, which is a serious security risk. Storing them in local text files makes them vulnerable to accidental leaks or unauthorized access, especially in distributed systems. Likewise, hard-coding keys in container environment variables still leaves them exposed to inspection and lacks the security features Key Vault provides. Therefore, the safest and most scalable way to manage secrets in production is by storing them in Azure Key Vault, ensuring encryption, controlled access, and automatic rotation of credentials. Question 53. Which two features make Azure AI Vision a strong choice for digital asset management DAM scenarios? Select two answers. A. It can describe and categorize images automatically. B. It can extract text and objects from images. C. It can build custom models for invoice data. D. It can translate extracted text into multiple languages. E. It can summarize long audio files. The correct answers are A. It can describe and categorize images automatically, and B. It can extract text and objects from images. Now let's go over why these two options are correct. Azure AI Vision is designed to understand and organize visual content by providing automatic image captions and categorization, making it extremely useful for managing large image libraries in digital asset management systems. It also performs OCR and object detection, allowing it to extract meaningful text and objects directly from images, which improves searchability and metadata tagging. In contrast, building custom models for invoice data falls under Azure AI Document Intelligence. Translation of extracted text is handled by Azure AI Translator, and audio summarization is a function of Azure AI Content Understanding, not Vision. Therefore, Azure AI Vision stands out for its ability to analyze, label, and extract valuable information from visual assets, streamlining digital asset workflows effectively. Question 54. Developers can create applications that use a trained custom vision model for image classification in multiple programming languages. Which statement accurately describes this capability? Select one answer. A. Only C# supports the Custom Vision Prediction SDK. Other languages must use the REST API. B. Python supports only training but not image prediction for custom vision. C. Developers must use Azure Functions instead of SDKs to call the prediction API. D. The Custom Vision Prediction SDK is available for several languages, enabling image classification from code. The correct answer is D. the Custom Vision Prediction SDK is available for several languages, enabling image classification from code. Here's the explanation. Azure Custom Vision provides SDKs for multiple programming languages, including C#, Python, and JavaScript, allowing developers to integrate trained models directly into their applications. This means developers can perform image classification or object detection without needing to manually call REST APIs every time. The other options are incorrect because the SDK isn't limited to C#, and Python supports both training and prediction, not just training. Also, while Azure Functions can call APIs, SDKs offer a simpler, language-specific interface for integration within any type of app. Therefore, Azure's Custom Vision SDK provides a flexible, cross-language way for developers to bring machine learning-based image classification directly into their code. Question 55. For each statement below, indicate whether the answer is true or false. The data source for an indexer can be an Azure Blob Storage container, a database, or another type of storage. True. Each skill in the pipeline can use the output from previous skills as input. True. Skills always run at the top level of the document hierarchy. False. The indexer must manually trigger each skill in the pipeline. False. Now, let's go through the explanation. The indexer in Azure AI Search can connect to different types of storage, such as blob containers, databases, or document stores, allowing it to extract and process data from multiple sources. Also, the skill set pipeline allows skill chaining, meaning that the output of one skill becomes the input for the next, creating a seamless enrichment flow. However, skills do not always run at the top level of the document hierarchy. They can operate on nested elements, such as individual images or sections of a document. Lastly, the indexer automates the entire pipeline once configured. This means you don't need to manually trigger each skill, as the indexer runs them sequentially during the enrichment process. In summary, Azure AI Search indexers are flexible, automated, and support multi-level enrichment pipelines for efficient data processing. Question 56. Fill in the blanks by selecting the correct options from the drop-down menus. The enrichment pipeline combines metadata from the data source with fields generated by skills to build a complete searchable document. Now, let's explain this. In an Azure AI Search enrichment pipeline, metadata from the data source refers to the core document properties, such as title, author, or file path, that are extracted first. These metadata fields provide the structural foundation of the document. Next, fields generated by skills are added through AI enrichment. Skills such as language detection, key phrase extraction, or OCR text recognition enhance the document's content. Together, these outputs expand the document beyond simple metadata, turning it into a rich, searchable index. This structured combination of metadata and enriched data enables more intelligent, accurate, and contextual search results within Azure AI Search. Question 57. Arrange the following steps in the correct sequence to configure built-in AI skills for use in an enrichment pipeline. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Correct order. Ensure access to an Azure AI Services resource. Define a skill set including selected built-in skills. Assign the skill set to the indexer. Run the indexer to apply the enrichments. Here's how it works. When setting up built-in AI skills in Azure AI Search, you must first ensure access to an Azure AI Services resource, since it provides the cognitive capabilities like OCR, key phrase extraction, and language detection needed for enrichment. Next, you define a skill set, specifying which built-in skills will be used and how data will flow between them. After defining the skill set, you assign it to the indexer, linking your enrichment process to the data extraction and indexing pipeline. Finally, you run the indexer, which processes your content, applies the configured AI skills, and enriches the data before it's stored in the search index. This structured sequence ensures a smooth integration of AI enrichment within Azure AI Search, enabling smarter and more searchable data. Question 58. A document analyzer returns coordinates and word-level confidence scores for each text segment. What additional insights do these details provide? Select one answer. A. They replace the need for field definitions in the analyzer schema. B. They show the spatial layout of text and help visualize how fields appear in the original document. C. They indicate network latency between client and service. D. They determine which pre-built analyzer template was used. Correct answer, B. They show the spatial layout of text and help visualize how fields appear in the original document. Now, here's the explanation. The coordinates and confidence scores that a document analyzer returns provide more than just text recognition. They reveal the spatial arrangement of words, lines, and paragraphs within the original document. This helps users visualize how fields and data were positioned, offering valuable context for layout-based understanding or validation. For instance, in a scanned invoice or form, these coordinates can be used to rebuild the structure of the document visually, ensuring that extracted data aligns with where it originally appeared. Ultimately, this feature enhances contextual understanding and visualization, but does not replace the analyzer's schema or field definitions. Question 59. For each description in the option column, drag the correct model name from the item list into the correct match column. Each item may be used once, more than once, or not at all. Extracts common fields and values from invoices. Invoice model. Extracts common fields and values from receipts. Receipt model. Unified U.S. tax model covering W-2, 1098, 1099, and 1040 forms. U.S. tax model extracts fields from U.S. driver's licenses, EU IDs, driver's licenses, and passports. ID document model extracts contact details such as names, organizations, phone numbers, and emails. Business card model extracts account identifiers, balances, and transaction rows from statements. Bank statement model. Now let's go over the explanation. The invoice model is designed to extract structured data like vendor names, totals, and invoice dates, making it ideal for standard business invoices. Next, the receipt model specializes in identifying merchants, items, and totals from receipts generated at point-of-sale systems. Similarly, the U.S. tax model focuses on standardized tax documents, such as W-2, 1098, 1099, and 1040, ensuring accurate extraction of tax-specific fields. Meanwhile, the ID document model handles driver's licenses and passports, capturing holder details and document metadata. In addition, the business card model extracts information such as names, organizations, and contact details, making it useful for digitalizing professional contacts. Finally, the bank statement model processes financial documents to identify accounts, balances, and transaction line items efficiently. Unused models include the layout model, which focuses on structural layouts like paragraphs and tables, and the general document model, which extracts general text and key values without being tied to a specific form category. Question 60. When submitting REST API requests to the Content Understanding Service, what additional query parameter must always be included in the URL? Select one answer. A. API version. B. Subscription ID. C. Resource group. D. Tenant name. The correct answer is A. API version. Now, let's move into the explanation. The API version parameter is mandatory in every REST API call because it specifies which version of the API should be used. This ensures compatibility and consistent behavior as services evolve over time. On the other hand, subscription ID forms part of the resource's endpoint rather than the query string. Similarly, resource group belongs to the resource path, not the query section of the URL. And tenant name only identifies directory context, not API versioning. Therefore, including API version in the query string guarantees that the API call references the correct and supported version of the Content Understanding Service.